The purpose of this PowerPoint is for you to attempt to complete a past paper question. It's split into 3 different sections. In the first section, you're going to be given the exam question, and the aim is that you just try it on your own and you see how far you can get through the past paper question. Hopefully you'll be able to do it all on your own. If you find that you're struggling, then you can move on to section 2, where I'm going to give you a few little hints and some tips on how to perhaps get started, so then you can have another go at the past paper question. And if you're still totally confused, then you can move on to section 3, where I'll go through the whole question in lots of detail. So here's a past paper on trigonometry. Part A is counterexample, and then part B is solving an equation. So press pause now and have a go at it on your own. If you manage to do it all, then you can check it, because I've put the mark scheme at the end of the PowerPoint. So press pause now and have a go at this question. So if you're watching this slide, then it should mean that you've already tried the question on your own and you just need a few hints perhaps to get you started. So I'll just give a couple of hints for A and B. Looking first of all at part A, it's asking us to show by counterexample that this statement is false. Now a counterexample is just one example. So for this it would be a theta value that doesn't work in this statement. So I would split it up into the left hand side and the right hand side. Pick a value for theta, and at first it can be as simple as using trial and error. So just pick a random number for theta, work out what the left hand side would be, work out what the right hand side would be, and hopefully you'll find two things that are different, because we want to show that they're not equal. So trial and error, see if you can find a theta value that would give two different answers. Moving on into part B. In part B, we've got an equation to solve. We've got to try and find all the values in the range 0 to 360. And I'm looking at this equation, and the first thing that jumps out to me is that there's a mixture of two different trig functions. There's sec and there's tan. Now, if they were all the same, it would make this question much easier. If they were all sec or all tan, this question would be much easier. So that's going to be our first goal, to try and make them all match. Now there is a trig identity that connects tan with sec. You'll have it in your notes, but I'm just going to remind you of what that trig identity looks like. 1 plus tan squared is equal to sec squared. If you haven't memorised this trig identity yet, you definitely need to memorise it now. 1 plus tan squared is always the same as sec squared. So that means that we can replace the sec squared theta in this question with 1 plus tan squared theta. Then we're not going to have the mixture of sec and tan anymore. Everything will be written in terms of tan, and it will be a quadratic. So you'll end up with a quadratic to solve. Quadratic in tan. How you solve that quadratic is up to you. Sometimes factorising is quick, sometimes they don't factorise, so you could use the quadratic formula. Some different ways of solving the quadratic, that's entirely up to you. Right, press pause now and have another go, see if that's helped you to get through this question. If you get through it all, you can check your answers at the end using the mark scheme. If you need to see the question gone through in detail, then I'm going to do that on the next slide, but don't watch that until you've tried the question out on your own. Okay, I'm now going to go through this question, so if you haven't tried it on your own yet, please stop me. Now in part A, I'm just going to pick a random value for theta, a bit of trial and error. I'm going to see if I can find one where the left hand side and the right hand side give different values. Sorry about the buzzing in the background. So if I look at the left hand side, I'm going to pick a random value for theta. I think I'm just going to pick 20, see if 20 works. So on the left hand side, I'll have tan of 2 times 20, which is 40. And on the calculator, tan of 40 is 0.8391. I've rounded it to 4 decimal places. For the right hand side, I could do 2 tan of 40 over 1 plus tan of 40 squared. So if I type that in on the calculator, 2 tan of 40 over 1 plus, open brackets, tan of 40, close brackets, squared, and it turns out to be 0.9848. So the left hand side does not equal the right hand side. So I've found an example that shows that this statement is not true. So that's part A done. I'm going to go on to a new slide now for part B. So now I'm going to look at question B, and it's asking us to solve this equation. It's got a mixture of tan and sec, and we don't want to see that mixture. I'd rather them all match. So for this question, you need to know the trig identity that 1 plus tan squared is always equal to sec squared theta. So that's a trig identity that you've learned this year that you need to memorise. If you don't know that, then this question is going to be very, very difficult. So in this question, where we see the sec squared theta, I'm going to replace that with 1 plus tan squared theta. Now this one's got a 2 in front of it, so I'll keep the 2, and then where it says sec squared, I'll put 1 plus tan squared, but I'm going to put it in a bracket, because on the next line I'm going to need to times all of that by 2. You could do that on this line if you wanted to. The right hand side I'm just going to copy as it is for now. So now I can expand this bracket, so 2 plus 2 tan squared theta equals 8 minus tan theta, and I'm going to get everything onto one side, as we always do with quadratics, because we want one side to equal 0. So on the left, let's bring everything over to the left. I'll have 2 tan squared theta plus tan theta, if I bring the minus tan over, and then if I bring the 8 over, 2 take away 8 is minus 6, and then this equals 0. I'm going to try and factorise this one. I'm hoping that it'll factorise. If it doesn't, then I can always resort to using the quadratic formula, but I find factorising much quicker if it works. Okay, so I've put the 2 in. Now I'm going to try and make that 6. I'm thinking 2 times 3 is 6. If I put the 2 there and the 3 there, 2 times 3 is 6. And then if I look at the outsides and the insides, I'm going to get a 4 and a 3. 4 tan theta and 3 tan theta, and I can make that into a 1. So what I need is a positive 4 and a negative 3, because now if you look at the outsides and the insides, I've got a 4 tan theta, take away 3 tan theta, which is 1 tan theta, and then minus 3 times 2 is minus 6. If I hadn't managed to factorise it, then I would have used the quadratic formula, and I would have put A in as 2, B would have been 1, and C would have been minus 6, and that would have worked just as well, and that would give us the same 2 values for tan theta. From the first bracket it would be 3 over 2, and then from the second bracket it would be minus 2. So I'm just carrying on with question B. So on the last slide I had tan theta equals 3 over 2, or tan of theta equals minus 2. So now on the calculator, I'm going to do the inverse tan of each of these to get some answers. So make sure you're in the right mode. This question is in degrees, so I'm in degree mode. I'm going to do shift tan of 3 over 2, and that gives me 56.31. I've rounded there to 2 decimal places. It didn't tell me what to round to, but I've just chosen 2 decimal places as a sensible way to round. For the other one, I'm doing shift tan of minus 2, which is minus 63.43. Now looking at those 2 answers, one of them is in the range. Remember that the range was 0 to 360, but the other one is not. Now to make sure that I've got all the answers, I'm going to do a cast diagram. You don't have to use the cast method. If you prefer to draw the tan graph, that's absolutely fine. I just tend to use the cast method, it works well for me. So if I draw on the 56.31, that's the one that the calculator gave me. And then looking back at the equation that I'm solving here, tan of theta equals 3 over 2. 3 over 2 is a positive value. So I'm looking for the ones where tan is positive. So I'm going to circle the 2 quadrants that I need. Those are the 2 quadrants where tan is positive. So I need to fill in the one in the t quadrant. So for that one, I'm going to do 180 plus 56.31, and that's 236.31. So there's another answer that I can add to my final list at the end. Now I'm going to do a cast diagram for the other value that I had. So this one gave me minus 63.43. And on this one, tan is negative, because tan theta was minus 2. So I need the quadrants where tan is negative. So I need the C quadrant and the S quadrant. There's already a value in the C quadrant, but it's not the one I want because it's not in the range. So I'm going to work out another one now to put into that C quadrant. So I'm just typing in on the calculator 360 take away 63.43, and it gives me 296.57. So that's better because it's in the range. Now I'm going to work out the one in the S quadrant. So for that one, I need to do 180 take away 63.43, and that is 116.57. So I'm now going to write a final list of answers. I don't want the examiner worrying about that minus 63.43. I want them to know that I know that that's not in the range. So I'm going to make a final list of theta values. So looking at the picture on the left, I've got 56.31 and I've got 236.31, and then from the picture on the right, I've got 116.57 and I've got 296.57. So those are my 4 final answers.